Your last example is an illustration of the intermediate value theorem, not only to make sure that it applies, but also to find all the C values for which the theorem does apply. So one thing that it does say at the beginning of the example is to verify that the intermediate value theorem applies. And so I want it written down that you have gone through all the conditions. I went ahead and wrote out the first condition, and that is the f is continuous on the interval from 5/2 to 4. Now, this is a rational function, so that's not always a given that you would have continuity. But this one's going to be discontinuous whenever there's a 0 in the denominator, and that would happen when x equals 1 and x does not equal 1 in that interval from 5/2 to 4. And so, so we do have continuity on this interval. The next thing that you have to do is to verify that your two endpoints, so the 5/2 is the A, and the 4 is the B. You have to verify that they do not equal each other. So f of 5/2, we would have 5/2 squared plus 5/2 over 5/2 minus 1. Now, you can use a calculator if you like, or you can just crunch this out. So that would be 25/4 plus 5/2. If we go ahead and get a common denominator, that would be 10/4. And then in your denominator, you have 5/2 minus 1. 1 would be 2/2. So that would give us 3/2. And then in your numerator, you've got 35/4. You're dividing that by 3/2, which means you're multiplying by 2/3. And upon simplifying, you'll get that f of 5/2 is equal to 35/6. So f of 5/2 is equal to 35/6. Then we have to verify f of 4. That should be a lot easier. So f of 4 will have 4 squared plus 4 over 4 minus 1. So that would be 16 plus 4. So we'll have 20 in the numerator and 3 in the denominator. So f of 4 is equal to 20/3, and therefore f of 5/2 does not equal f of 4. And then finally, you have to verify that the k value that you're interested in is in between those two y values that you have found. So we have to know a little bit about our fractions. So 35/6, that would be 5 and 5/6. So that's less than 6. So 35/6, that was f of 5/2, is less than our k value of 6. So now we have to check out 20/3, and so that would be 6 and 2/3, and so 6 is less than f of 4, and all of that work is simply verifying that the intermediate value theorem, which I'm going to abbreviate by IVT, applies. So that in no way lets you off the hook because you have not finished the problem. Finishing the problem is for you to find the value of C in the interval that's guaranteed by the theorem. All right, so to find C, you will simply set your function equal to the k value that you're interested in. So we'll set f of x equal to the 6. All right, so your f of x is x squared plus x over x minus 1. We're setting that equal to 6. So you have a fraction. You could multiply both sides by that denominator. So that would give us x squared plus x equals, and then distributing, we'd have 6x minus 6. So now we have a polynomial. We have to get one side equal to 0. So we'll have x squared minus 5x plus 6 equal to 0. And one way that you could solve this is by factoring, which I'm just going to go ahead and do. So that would be x minus 2 times x minus 3. You needed something that multiplied to 6 that would add to negative 5. So your negative 2 and negative 3 do that. And then setting each of those factors equal to 0. So if we set x minus 2 equal to 0, we find out that x equals 2. If we set x minus 3 equal to 0, we find x equals 3. Now, it's possible that you could have two c values, but we need to check out the interval. The interval was from 5/2 to 4. So from 2.5 to 4. Well, the 2 is not in that interval. So even though 2 is a solution to that equation, 2 is not in the interval, but 3 is. So 3 is in the interval from 5/2 to 4. And so your C that's guaranteed by the intermediate value theorem is 3. And those are the examples for homework 8. Good luck on your homework.